In this video, we are going to learn how to graph a piecewise function. So before we start, what is a piecewise function? So piecewise function is a function which is defined differently on different part of the domain. So that means if you pick the domain, if you look at the whole domain of the function, you can see there are different functions in a different part of the domain. So for example, we can look at this function. So if you look at this function, you can see that the first part of the function, that means for x less than 1, it is x plus 4. So that means it is y equal x plus 4 when x less than 1. And if you look at in between 1 and 2, you can see it is y equal 3. We call it y equal 3 because that's a y value. So y equal 3 between 1 and 2. We are including 1 without 2. And then for any value which is greater than 2, the function is y equal square root x plus 7. So that means you can see that there are three different functions for three different parts of the domain. So if you look at that in detail, so what's going to happen? So if you call those three functions part 1, part 2, part 3, so you can see that. So let's look at the whole domain. So we have the domain which is going from negative infinity to infinity, and you can see that this function is defined for all real numbers, because for each value from negative infinity to infinity there is something defined for that part. So what are the two important values here? So we have 1, so that's one value which is important here, and then we have 2. Those are the two values discussed in the domain. So you can see that for any value between, so I'm going to say those three parts are, so let's say this is part 1, and then this is part 2, and this is part 3. So you can see that the first part, which is going from negative infinity to 1, negative infinity to 1, and you can see that it is part 1. So that means for this part of the domain, so that is the first part. So for this part of the domain, the function is 1. So that is the valid function for that. And if you look at in between 1 and 2, in between 1 and 2, so here including 1, excluding 2, you can see that it is the part 2 of the function. And if you go from any value from 2 onward, so any value from 2 onward, so which is larger than 2, that means this side, and you can see that it is the function 3. So those are the three functions that we use for each part of the domain. So now let's look at those functions in detail. So we have this function. So what's going to happen? So let's look at what happened if, so we can say for x less than 1, so we have the function y equal x plus 4, and you know that this is a equation of a straight line. So that means if you look at the graph, so what's going to happen, so this is the function you get. So you're going to get the graph, so which is a straight line with slope 1 and the y-intercept 4. So that means it's going to go through 4 and slope 1. So that means you're going to get a function. So if you graph it, what's going to happen? So it's going to continue like that and going to go through, and then stop at because you can see it's only defined until number 1. So when you see 1, it's going to stop, and you can see that you cannot continue. So that means after that we don't have the function because it can stop at 1. And then on the other side, and you can see that it's all defined for all real numbers, all negative value. That means it's going to continue. So we're going to put an arrow to mean that it's going to continue all the way. So, and what is this value? And to find this value, exact value, you can say you can plug in 1 to the function. So you can see that it is 5, but it never reach 5 because that point is not included, but it's going to go closer and closer to 5. So that is the first part of the function for x less than 1. Now let's look at the other part. What's the second part? So you can see the second part, which is for 1 less than or equal x less than 2, and you can see that the function is simply y equal 3. So this is not difficult to draw. What does that mean? So it's 3 everywhere. but what we have is only between 1 and 2. So that means if the values 1 is here and 2 is there, so you can see this is 1 and 2. So that means function is only defined in this part of the region. So that means you have the value 3. So you can see so it's gonna so this part is not there, and then not there, and then you can see it's gonna start at 1. So which is a solid dot because 1 is included, and then it's going to continue that value 3 and stop at 2, which is not included. That means open, and then this part is not there. So that means we only have this part, and this is the value 3. It's exactly value 3. So this is the equation y equal 3. So those are the first two functions, and then we have the last function which is for so you can see that which is for x greater than or equal to 2. So we have so what function we have? We have y equal x plus 7 square root. So that means if you remember how to do the transformation, and you can see that this is simply the square root function shifted horizontally to the left 7 units. So you can see it is x plus 7. That means it's going to shift to the left side. So how many points? 7 points. So that means you can see this is very close to a square root function, but you want to shift it to the 7 shift to the left 7 units. So so that means if you graph it, what happens is going to start at -7 on this side. It's going to start at -7. And then the graph gonna looks like so, and then also you can see it's only valid after 2. So that means let's say this is 2. So you can see that so this, and then also at 2 if you plug in 2 you get 3. So that means so what happened, so this part is not included. So this is the regular square root function, but you can see this part is not there. But when it reach 2, it's going to start getting the value. So that means that's a solid dot, and it's going to continue after that. So that is the graph. That's a part of the function because it's only valid for x greater than or equal to. So, and then you can see that is the value 3 over there. Because if you plug in 2, you get 2 plus 7, which is 9. Square root means 3, so you get 3 over there. So there's something interesting happen actually. Even though those two functions like part 2 and 3, if you look at part 2 and so these are the parts. There's a part 1, and this is part 2, and this is part 3. And you can see that even though those part 2 and part 3 define differently, and you can see the ending value of the part 2, which is 3. And then so that's the ending value of part 2, which is 3, and also the starting value of part 3 also 3. That means one gonna stop and the other one gonna pick it up and then gonna continue. So now what we're gonna do, we're gonna combine these 3 pieces into one function. That's how you get the piecewise function. So that means we're gonna get this one. So if you graph all 3 functions in one, so what's gonna happen now, we're gonna combine all 3 into one. So so we're gonna get this graph now. So first part, so what are the numbers we need? So we have we can say 2, and then 4, 6 on the other side, -2, -4, -6, and then -7 here. So the values, so we can put those values, important values. So we can see 0, 2, 4, 6, and then -2, -4, -6. Those are the important values. And then so we have the first part. You can see the first part go from so which is actually also we need the axis values on this side also. So we have 2, 4, 6, and you don't have to use the exact same scale for both axes. You can have one scale for x-axis, and you can have another scale for the y-axis. So now we're gonna bring them together. So the first part we have is, so we have the line which is go up to 1. So that means if you draw the line, so so it's gonna go from here. So you can see, so that's the line, but it's gonna go only up to 1. So it's at 1, it's going to stop, and you can see it's open dot. That's the first part of the function, and it's gonna, we draw arrow to mean that it's going to continue. And then the second part, between 1 and so it was between 1 and 2. So you can see between 1 and 2, so we have a value 3. So that means if we have 2, 4 and 6, so the value 3 is here. So that means you can have, so it's a closed dot at 1. That's 1. So there's a closed dot, and it's gonna end up at 2, which is open dot. So that's the second part of the function. And then what's going to happen, so we have that square root function, but it's only the last part after 2. So that means we're going to get, so square root function starting at 7, and it's going to continue. So it's going to go like that. So it doesn't look like square root. So it's going to go from here. It's going to go like that. We normally draw until the end of the axis. So we have this. And then we notice that the ending value of part 2, so again, this is the part 1, and this is part 2, and this is part 3, and we notice that the ending value of part 2 equal the starting value of part 3. That means this can be a solid dot. So that may not happen in other cases. So that is the graph of the piecewise function fx. And you can also see that the domain of this function is all real numbers. That means negative infinity to infinity. And you also see that the range, if you look at the range of this function, and you can see that it's going to go all the way to negative infinity and all the way, because curved function grow indefinitely. That means the range is also negative infinity to positive infinity. So this is how you graph a piecewise function, looking at each piece differently and combining those 3 pieces or a number of pieces depending on the function together. So as practice problems, try to graph these 2 functions. So you can find the solutions to these 2 functions in a separate video.